Okay, dealing with cosine, we will move quicker this time because it's exactly the same concept as sine. Remember, C-A-S-T. So cosine is positive out there, and where it says C, all of them are positive and all of them are negative. Why? Because that isn't a C. The only thing positive over here is sine and tangent. Oops, I should have done that in black. Every single terminal ray in the A is positive, and cos is positive over there. Okay. Cosine, we spoke last lesson about this terminal ray, and I was drawing red lines everywhere. This lesson, I'm going to be drawing blue lines everywhere, blue being the x component. So again, if that's 30, you would know that that's 1 and that's root 3. So this is a point would be root 3, 1. That value is positive, therefore cos, we know cos is A on H, so it's root 3 on 2. And because our x component is positive, that answer is positive. However, the minute I get an angle out there, my answer is going to be negative, because whatever that angle is, when I draw my blue line out here, the x-axis is negative over here. Over here, x is negative. So it doesn't matter where on this side I'm going to draw my terminal ray, this blue line that's going to come out to meet all of them, they're all different, they're all going to be negative. So cos is negative everywhere out there. That was a bit faster than last time. Let's do a question. So again, I've got to draw a triangle with a 150 degrees in it, and I can't. So there's my 150. I need to get this angle here, which is 30. The little acute angle measured off the x-axis is called my reference angle. My reference angle tells me what sort of triangle to draw. I need to draw a triangle with a 30 in it. 30. So that's 2, 1, root 3. And we know that cos is A on H, which is root 3 on 2. So there's our value. So we can say cos, hey, why is that our value? Cos is the ratio of side lengths of A on H. Hopefully you can see that the shape of that triangle and the shape of that triangle, they're the exact same triangle. Therefore, the ratios of A on H are going to be the same no matter what. So we can say that cos 150, the value was going to be root 3 on 2. The only thing we've got to work out is whether cos is positive or negative. So if I was to draw my blue line out here, all I really need to ask is, of this point on the terminal ray, my cos is the x component. So that's negative in quadrant 2. Therefore, cos is negative in quadrant 2. Therefore, this answer is not positive root 3 on 2. Cos 153 is negative root 3 on 2 because it's over in that quadrant. Okay. 4 pi on 3. We love radians. Where's 4 pi on 3? So that's 1 pi on 3, 2 pi's on 3, 3 pi's on 3, 4 pi's on 3. So that's 4 pi on 3. And we need this little green. That angle there is pi on 3. So I need to draw a triangle. That's my reference angle. Reference angle is measured is an acute angle measured from the x-axis. I need to draw a triangle with a pi on 3 in it. There's my pi on 3. Pi on 3. Okay. Cos is A on H. So there's my angle. That's my A. That's my H, which is 1 on 2. Okay, so we can say, therefore, cos 4 pi on 3 is 1 on 2. We know the value from our exact value triangle. We just need to determine whether it's positive or negative. So I need my little blue line out here. So I'm thinking, this point, what's its x component? Is it positive or negative? Well, x is negative out there. So you're going to go cos is the x component. X is negative in quadrant 3. Therefore, cos is negative in quadrant 3. So guess what? I put a negative there. So what's cos 4 pi on 3? Negative a half. Okay, that's great. Get going, do some practice.